students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as Solutions and Colligative Property. We're going to see sums based on osmotic pressure. Osmotic pressure. Right? Now, let's see this. Here pi represents osmotic pressure and C represents molar concentration. Right? Now let's see the formulas of these. Right? Pi V is equal to nRT, then pi 1 V1, pi 1 V2 is pi 2 V1, then you have pi is CRT and you have pi 1 upon pi 2 is C1 upon C2. Pi 1 upon pi 2 is C1 upon C2. Okay, let's start with the numericals, guys. Please take out. At 298 Kelvin, 4.5 grams of glucose, 4.5 grams of glucose whose molar mass is 180 is dissolved in 100 ml of water. Is dissolved in 100 ml of water. Find the osmotic pressure. Find the osmotic pressure if R is 0.0821 liter atmosphere moles per Kelvin. Let's find out N first. Number of moles. That's weight upon molecular weight. So that should be 4.5 upon 180. So N should be equal to 4.5 upon 180. Once I have this, volume is given to me. I can straight away say that pi V. I can use the second formula. Pi V is equal to nRT. Therefore, I can say pi is equal to nRT upon V. So that's how I'll get my value of osmotic pressure. The answer for this sum should be 6.116 atmosphere. Next, take on next sum please. Find the temperature of the solution. Find the temperature of the solution of cane sugar. Find the temperature of the solution of cane sugar find the temperature of the solution of cane sugar whose molar mass is 342 grams per mole containing 17.8 grams per liter of cane sugar and has an osmotic pressure of 1.2 atmosphere and has an osmotic pressure of 1.2 atmosphere when R is 0.082 liters atmosphere per mole per Kelvin. Now, they said that I can say that 17.8 grams of cane sugar is dissolved in 1 liter of solution. How do I know 1 liter of solution, guys? Because look at the unit. They said 17.8 grams per liter. Now, first let us find out number of moles. Number of moles I can say is nothing but weight upon molecular weight. 17.8 molecular weight 342. So I'll get the value of N from here. Once I have this, I'll get N is so many moles. Hence, I can say that the molarity is going to be so many moles. Whatever is the value of N that you get, so many moles per liter. Because that was the amount of cane sugar that was dissolved in 1 liter of water. Now, I can say that osmotic pressure is CRT. Molarity is nothing but your concentration. So I know my concentration. Molarity is a method to measure concentration. So I know concentration. R is given to me. Temperature CRT. T is what they have asked you to find out. Pi is given to me. CR is given to you. So you will come to know the temperature at which this will occur. The answer for this sum should be, answer is 281.4 Kelvin.
So what will be molarity?
Molarity?
Yes, so what will be the value of N will be molarity?
Yes, the value of N will be molarity. Okay, now next sum please. At 303 Kelvin, at 303 Kelvin, 30 grams of glucose, 30 grams of glucose having a molar mass of 180 has an osmotic pressure of 4.91 atmosphere, has an osmotic pressure of 4.91 atmosphere. Has an osmotic pressure of 4.91 atmosphere. Guys, I'll repeat the sum, just check this out. At 303 Kelvin, 30 grams of glucose per liter, just make that correction, 30 grams of glucose per liter having molar mass of 180 has an osmotic pressure of 4.91 atmosphere. Find the concentration of the solution if the osmotic pressure, find the concentration of the solution if the osmotic pressure is changed to, if the osmotic pressure is changed to, if the osmotic pressure is changed to 1.5 atmosphere. First, let us find out the concentration of glucose. C1 is nothing but weight of the solute upon molecular weight. So that's 30 divided by 180, because 30 grams of glucose has been dissolved in 1 liter of solution. Once I have this, then I can use the fifth formula. I can say pi 1 upon pi 2 is C1 upon C2. I know pi 1, pi 2, I know the initial concentration, I can find out the final concentration. The answer for this sum should be 0.0509 molar. Next, take on next one please. At 300 Kelvin, the osmotic pressure of the solution is 3.9 into 10 raised to 5 newtons per meter square. Find the volume of the same solution containing 1 mole of solute in 10.5 meter cube, containing 1 mole of solute in 10.5 meter cube and having an osmotic pressure of 2.82 into 10 raised to 5 newtons per meter square. Straightforward, pi 1 V1 is equal to pi 2 V2. You have pi 1, pi 2, V2. V1 is the only unknown. You should be able to get this answer. The answer for this sum should be 7.59 meter cube. Next, take on next one please. 1 liter of solution of sucrose, 1 liter of solution of sucrose having molar mass 342 grams per mole is isotonic with 6.6 into 10 raised to minus 3 kgs per liter of urea having a molar mass of 60 into 10 raised to minus 3 kgs. Calculate the mass of sucrose. Molar mass of sucrose is 342 grams per mole. Okay. Now what do you mean by isotonic? Isotonic means the osmotic pressure is the same. Okay. Now we already know that pi is equal to CRT. They haven't said that the temperature is changing. Gaseous constant will not change. So if I can say as isotonic That means pi 1 will be equal to pi 2. Therefore C1 RT should be equal to C2 RT. That means I can say concentration of sucrose should be equal to concentration of urea. Concentration is nothing but weight upon molecular weight. That means this is going to be nothing but mass of sucrose upon molar mass of sucrose should be equal to mass of urea upon molar mass of urea. Now I presume I know most of the things. Mass of sucrose upon molar mass is 342 is equal to mass of urea 6.6 into 10 raised to minus 3 upon molar mass 60 into 10 raised to minus 3. When you solve this, you should get the answer for this. The answer for this should be 37.62 into 10 raised to minus 3 kgs. Guys, let's continue and let's also finish sums based on molar mass of solute using osmotic pressure. Right? Let's do one more time here. Let's continue and let's do sums based on molar mass of solute, from osmotic pressure. Right? First formula, M2 is equal to W2 RT upon pi B. Next formula, okay, that's it. That's the only one formula that I need to use here. Right? Take down the sum, please. Take down the sum, please. At 37 degrees Celsius, the osmotic pressure of a solution containing 6.8 into 10 raised to minus 3 kgs of protein, containing 6.8 into 10 raised to minus 3 kgs of protein per 1 into 10 raised to minus 4 meter cube of solution is 3.02 into 10 raised to 3 pascals. Find the molar mass of protein. Find the molar mass of protein if gaseous constant is 8.314 joules per Kelvin per mole. Straightforward. M2 is equal to W2 RT upon pi V. All the values are given to you. You have to just multiply, divide and get the answer. The answer for this should be 58.06 kgs per mole. Next, take on next one, please. Calculate the molar mass of a solute. Calculate the molar mass of a solute when thousand centimeter cube of a solution contains 1000 centimeter cube of a solution contains 4.34 grams of solute, contains 4.34 grams of solute and has an osmotic pressure of 2.55 atmosphere at 298 Kelvin. If gaseous constant is 0.0821 liters atmosphere per Kelvin per mole. Again, straight multiplication, one formula only you have. M2 is W2RT upon pi V. W2RT pi V. Everything is given to you. You should be able to get the answer for this. The answer for this should be 41.64 into 10 raised to minus 3 kgs per mole. Next, take on next one please. At 20 degrees Celsius, a solution contains 34.2 grams. A solution contains 34.2 grams of cane sugar and has an osmotic pressure of 2.42 atmosphere. Has an osmotic pressure of 2.42 atmosphere. Find the volume of the solution. Given that the molar mass of cane sugar is 342 grams per mole. You still use the same formula. I can say that M2 is W2RT upon pi V. They've asked you to find out V. Therefore, I can say V is W2RT upon pi M2. Right? When you solve this, you should get this answer as 0.9945 liters. Next, let's see the next one, guys. At 12 degrees Celsius, at 12 degrees Celsius, a particular amount of organic substance, has a molar mass of 196 grams per mole and is dissolved in 2 liters of water to give an osmotic pressure of 0.54 atmosphere is dissolved in 2 liters of water to give an osmotic pressure of 0.54 atmosphere. Find the mass of the solute. Find the mass of the solute. Find the mass of the solute if gaseous constant is 0.0821 liter atmosphere per Kelvin per mole. You still use the same formula, M2 is equal to W2 RT upon pi V, but here they've asked you to find out W2. So this is going to be pi V M2 upon RT. Pi V M2 RT, all the values you have, you should get this answer as 9.04 grams. Right? That finishes that chapter. We'll stop this here for a day. Thank you very much.